Hey guys, it's time to move along in our next unit here on polynomials to talk about a different operation than what we talked about in our previous video, which was addition and subtraction. This video here is going to talk about multiplication of polynomials. So there are a couple steps to keep in mind when we're multiplying polynomials out. Number one, of course, we always want things written in standard form, that's highest to lowest variable exponent. But besides that, we have these steps listed here that we're going to follow consistently for each of our problems when we're applying polynomial multiplication to them. So it could be a simple, straightforward, abstract problem. It could be something a bit more concrete, like a word problem that we'll see in a bit that ties to the real world. But in any case, you're going to follow these steps, is what I would recommend anyway, to multiply polynomials. So the first step here is we're going to use the box method to set up rows and columns. This is very similar, by the way, to how we multiplied out complex numbers in our first unit and how we double checked our answers for factorizations in our last unit. Main difference here is that we will have a lot more things to combine at the end of our problem. But otherwise, we've already talked about the product rule. We already know how to multiply numbers, of course, and this just ties things together quite nicely. So for this problem, for example, we have three different terms in our first parentheses, three in our second. So we should have 3 columns and 3 rows set up. This, by the way, is one of the more in-depth or complicated examples that we'll have. I'll have a few other examples that might look like they're complicated, but really, if you can do this problem here in blue, you're in pretty good shape with polynomial multiplication in general. So step one, set up a box with rows and columns, and it doesn't matter whether you put your first parentheses on top or on the side. Just make sure you have first parentheses represented somewhere, as well as that second parentheses. In this case, I like to set that one up on my left side of my box. Step 2 is going to be to fill in these boxes, and the way that we're going to do that is by multiplying our coefficients and adding our variable exponents according to the product rule. So what that would look like is first row times first column to fill in that first box will be an invisible 1 times 2, which is 2, and we add our variable exponents. X squared times x squared, in this case 2 plus 2 is 4. Continue that process for all 9 of your boxes. 2 times -4 is -8. This is like an invisible exponent of 1. And 2 plus 1 gives us a variable exponent now of 3. Continue. In this case, that will be a 4x squared. Since 2 over here does not have a variable at all, x squared carries over. Continue to your next row. So on and so forth through all of your boxes. So 1 times 1 is just a 1. X times x squared is x cubed because that's an invisible 1 as your exponent. You'll see now that we can start looking at later on combining like terms, matching those exponents like we did in our last video, and then adding or subtracting the coefficients. We'll get to that shortly. But continuing to multiply and fill in all of our boxes. X times x is x squared because 1 plus 1 is 2. And we have 2x. We have 5x squared, -20x, and lastly 5 times 2 is positive 10. Okay. So we filled in our boxes, and that's going to lead to our last step for polynomial multiplication, and we're going to combine like terms. And the way that we do that, once again, as we saw in our last video, add or subtract the coefficients of the terms that have matching variables, and you match them according to their exponents. So in this case, 2x to the 4th doesn't match with anything else in our box. By the way, I like to cross things out as I go through my problem to make sure I've accounted for everything. I would recommend that whether you're adding or subtracting or rewriting problems. If you're putting something somewhere as to simplify a previous step, it doesn't hurt to go through and mark where you've applied different parts of your problem and where you have not. So notice that we have a -8x cubed that will be combined with a positive 1x cubed. So check those off. These two will be combined shortly. Okay. Then we have this diagonal that we're going to combine as well. So that would be a positive 4x squared up at the top a negative 4x squared in the middle, and a positive 5x squared bottom left. Okay. Next set of terms that we can combine, negative 20x, positive 2x. And lastly, that positive 10 can't be combined with anything else. So we're just going to leave that by itself. All right, now we can go ahead and, like we said, add or subtract those coefficients as the case may be. Those coefficients are the numbers in the front that you're multiplying each variable by. So in this case, 2x to the fourth, part of our final answer. Negative 8, positive 1, combine those, that'll give you a negative 7, x cubed. So we've already added our exponents. We're not adding our exponents down here anymore. You only add exponents according to the product rule when you multiply those different terms. You're not multiplying down here, you're adding or subtracting. Okay. 4 minus 4 will actually cancel out, and that leaves us with 5x squared. Negative 20, positive 2 gives you a negative 18x. Be careful, always double check your answers, especially using some form of technology such as a calculator. And because our answer is written in standard form, highest to lowest exponent, this is actually the answer to our polynomial multiplication problem. You can see that it's a quartic polynomial. Quartic because the degree is 4. It's a polynomial because we have 1, 2, 3, 4, 5 different terms. Our lead coefficient is a 2. The coefficient of something like x squared would be a 5, or the coefficient of x is negative 18. Just so that you recall all of those concepts from our previous videos, yeah, features of polynomials can still show up at this point after you've simplified your problem completely. So that is one example of polynomial multiplication according to the steps that we will be using for other types of problems, including word problems. So you might take a look at this and say, oh, that's a lot of words. How am I going to be able to solve this problem? It's going to be much more complicated than what we just did. Actually, it's not. You just have to take it one piece at a time and maybe underline key parts. For example, if a student took a piece of paper and did something with it, what I would recommend is just drawing what a piece of paper looks like. It's a rectangle, right? Okay. And the length of this paper is 8x, and the width is going to be 3x. So underlining length of 8x, width of 3x. You're looking at paper. What the student did was she cut 5 inches off both sides. Okay. Now how's that going to look? Well, you can visualize that. Snipping paper. Might be left with this little scrap on the top left. And the question is, what's the new area of the paper in square inches? So in this case, you have to think about what operations has the student performed, and then what are you going to do based on that. If you're cutting off paper, is the paper getting bigger or smaller? And very clearly the paper is getting smaller. She's subtracting 5 inches from both sides. We only want to find the area of the paper that's left over, and that would be this. This is the area. Right. All of this other bit got cut off. And to find area, you just need to remember that we need to multiply length times width, which now is a little bit different than what we started with. We started with 8x times 3x. Now it's going to be 8x minus 5 times 3x minus 5. So you can write that in any order, by the way. That's going to become important shortly. In other words, you could have put 3x minus 5 in the first parentheses and 8x minus 5 in the second. Doesn't matter, at least not for this problem. For a later problem, it will. So it's going to be the box method once again. Okay. Multiply things out, multiply coefficients, add variable exponents where the boxes allow. So 24x squared, negative 15x, negative 40x, and negative times negative is positive. 5 times 5 is 25. Okay, and that gives us a final answer if we're going to combine like terms as well. 24x squared. We can combine these terms here. They have the same variable, x to the invisible power of 1. Negative 15 and negative 40 give a bigger negative number, negative 55x, and that positive 25. This is your area in square inches of the new piece of paper for your problem. Okay, and that leads us to one last problem, which deals with volume. Again, not so difficult, although you might be thinking, okay, so volume, we're multiplying two different times here, length times width and width times height. Or I should say length times width and then the result times height. What's important here though is to remember that, for example, 2 times 5 is the same as 5 times 2. Now why is that important to remember? Because here's what you could do to solve this problem. You could multiply 3x squared minus 8 times one of those other two sides. You could do 3x squared minus 8 times x plus 4 first if you wanted to. What I'll recommend though is that whenever you have conjugate pairs, like we have here, a plus and a minus, x plus 4, x minus 4, multiply those out first because you'll find that things cancel out immediately. So in other words, what I want you to do when you have length times width times height to work with is see what would be the simplest to try to simplify first, and in this case it's going to be those conjugate pairs. The reason is that, as we saw in our first unit, some things will cancel out. For example, x times x is x squared, x times 4 is 4x, x times negative 4 is negative 4x. We can already see that these boxes will cancel out. Positive 4x, negative 4x, those are going to cancel. And that's going to leave us with x squared minus 16, which is much simpler to work with at the next phase of our problem. I'm going to actually let those of you watching this video simplify this part on your own. We're going to take the result, and that would be x squared minus 16. And to find the volume, don't forget we need to not only multiply these two sides as we've done, we need to multiply by this last side as well. So take the result here, multiply it by 3x squared minus 8. Box method one more time, that will give you the result of what the volume is for that box or that cube or shape. So besides that, the only thing that you'll need to remember is that there are different ways to express polynomial operations. And that's one last thing I wanted to mention to conclude this video. Okay, there's some different notation to be aware of when we're talking about addition, subtraction, multiplication, and division. So for example, let's say I had two functions, f of x, 2x plus 5, g of x, 6x minus 7, and I wanted to represent that I wanted to ask you to add those two expressions together. There's multiple ways I could say that. I could say 2x plus 5 plus 6x minus 7. For example, in green right here. But another way I could phrase that question, where I'm asking you to add those two things together, is as follows. F plus g of x, f plus g just means add those two polynomials together. F minus g, of course, then means subtract those two polynomials in the right order, of course. And f times g means multiply those two parentheses together. This is just so that if I give you a question like, set up where f of x equals something, g of x equals something, and I say, find f plus g of x, you'll know, what does that mean? It means I need to add these things together. If I say f minus g of x, find that, subtract those two things, one from another. Or if I say f times g of x, find that, you would be multiplying those two functions together. It's not difficult once you get the background understanding of what the notation is, and hopefully that is something that you'll be able to do coming up on one of your assessments. So we'll be talking about polynomial division next in our video, so I'll see you then, and hopefully this helped as usual.